Hello everyone, my name is Glenda Amaral. I'm a PhD student at the University of Bolzano. I would like to thank you for the opportunity to present our work. It's a pleasure to be here. In our paper, we propose an ontology-based approach for the modeling and analysis of trustworthiness requirements. A central concept in our proposal is that of trust. Trust is especially important in the case of safety-critical services that can directly affect human lives, such as medical diagnosis, military operations, and vehicle driving, and also in the case of critical decision-making activities, such as security and finance, where significant assets are at stake. The advent of artificial intelligence technologies made it possible to build systems that drive a car, decide on a loan application, diagnose a patient, or kill an adversary in combat. Such systems signal a new era where software-intensive systems perform tasks that were performed in the past only by humans because they require judgment that only humans possess. As systems that make critical decisions are being developed with or without the AI technologies, it's essential that their users trust them in the same way they trust their doctors, drivers, or soldiers. These considerations call for studying a new class of requirements, which we name here trustworthiness requirements. But what exactly is trust? And what makes a system trustworthy? In this work, we'll answer these questions in terms of a recently proposed reference ontology of trust. This ontology defines trust as a complex mental state of a trustor composed of his intention of reaching a goal and a set of beliefs of the trustor about the trustee and its behavior, which are the belief that the trustee has the capability to perform a desired action, and the belief that the trustee's vulnerabilities will not prevent her from performing this action. One advantage of making the components of trust explicit is that this knowledge can be used as input to the definition of trustworthy signals that ensure trustworthy behavior. The identification of trust components is equally important to the assessment of risks related to the capabilities and vulnerabilities, which are the focus of stakeholders' beliefs. We rely on an ontology of non-functional requirements to define trustworthiness requirements as quality requirements. According to this ontology, non-functional requirements refer to qualities taking quality values in particular quality regions. It means that quality requirements constrain the level of presence of a quality in its subject. For example, being trustworthy is a constraint for agents or services to fall in the trustworthiness region of a space that also includes an untrustworthiness region. As a result, we propose a reference model of a well-founded ontology that characterizes the concept of trustworthiness requirements in the context of software systems, which we call here the ontology of trustworthiness requirements. We analyze the components of the trust complex mental state of the trustor in order to identify what the system should have for stakeholders to trust it. We believe that the concept clarification provided by this ontology promotes practical implications in terms of improving trustworthiness requirements specifications. Understanding the elements of stakeholder trustworthiness towards the system to be is important because they reveal the qualities and properties the system should have in order to be considered trustworthy and effectively promote well-placed trust. Another advantage of making the components of trust explicit is that this knowledge can be used as input to the definition of trustworthy signals that ensure trustworthy behavior. Finally, the identification of trust components are key for the assessment of trustworthiness-related risks that may arise when the requirements are not fulfilled accordingly. And it's all. Thank you very much for listening.